and welcome. I'm Jing Xu from the University of Technology, Sydney. Today, I'd like to share findings from a recent research project titled Are Inclusive Scientific Fields More Innovative?, co-authored with Renee Adams from Oxford University. Let's start with the big picture idea behind our research. There is a growing belief that diverse science is better science. That means when people from different backgrounds come together, they can produce more creative research. Most existing research has examined diversity at the individual or team level and found that teams including individuals from underrepresented backgrounds often generate more novel ideas. However, even when these teams produce novel ideas, they don't always gain traction. If there are barriers that limit the spread of ideas from less represented groups, then the overall impact of inclusiveness on a field's innovativeness becomes uncertain. So we ask, what if the issue isn't just about individuals or teams, but about the fields themselves? A field, through its associations, conferences, and journals, may influence the respect minorities receive. This brings us to our central question: does a more inclusive scientific field produce more innovative research? To answer this, we shifted the focus from individuals and teams to scientific fields, offering a broader, macro-level perspective that complements existing studies. Now let's talk about how we approach this. We constructed a country field year panel datasets covering over 180 countries and 160 scientific fields, spanning the years 1996 to 2022. The data came from Elsevier's Scopus. To measure inclusion, we focused on the share of female authors in each field and country. We chose gender as a proxy, not because our research was limited to gender, but because it offered a practical advantage. Gender can be inferred from names with much greater accuracy than race. To measure innovativeness, we used several indicators. First, we examined how broadly a paper drew on different research topics in its references. The idea is that papers citing a wide range of topics tend to be more original. Second, we measured the number of distinct research topics in a field. Third, we used the Blau Index, which captures how evenly research activity is spread across different topics. Finally, we look at how interdisciplinary the research was. For our analysis, we used the ordinary least squares models and addressed endogeneity concerns by including country, field, and year fixed effects, along with various controls. So what did we find? The table shows our main results. We regressed topic diversity measures and interdisciplinarity on female representation in a field country. The coefficients on female representation were statistically significant, positive in all four columns. This suggests a positive association between gender diversity in a field country and its topic diversity. In other words, more gender-inclusive fields tended to explore a wider range of ideas, draw from more diverse topics, and engage more in interdisciplinary research. In terms of economic impact, the effect varied across different measures. To illustrate the effect on distinct topics in a field, consider the following example. Imagine moving from a country-field combination where only 16% of authors are women. That's around the 25th percentile, to one where 37% are women, which is around the 75th percentile. That shift was associated with a 15% increase in the number of distinct research topics in the field. To sum up, our research showed that inclusiveness at the field level was associated with greater innovation in science. These findings come at a time when academic freedom and DEI initiatives are facing increasing scrutiny. Our results suggest that inclusiveness in science isn't just about social justice. It may also support scientific progress. They also highlight the importance of understanding and addressing the barriers that prevent individuals from underrepresented groups from advancing in the scientific community.